Okay, 4:30, I think we can start. So welcome to the IETF 110 role meeting. Please be aware that this meeting is aligned with the note well. We are not going to read it, but you have to follow in order to attend this meeting. So please help us with the code EMD. The minute takers, yes. And this is the Java chat as well available if you want to join. So this is our agenda. We will provide now a working group status, then Pascal with provide a status into the DAO projection draft. Michael goes through the enrollment priority, and then Raul with the updates, mopeds, and capabilities. And then open floor if time permits. So about the state of active internet draft, we have finally 4 main drafts into the RFC 800 queue. NPDAO, turn on RFC 8138, and our leave use of Ripple info. So good job done there. So today we're going to discuss about capabilities, DAO projection, enrollment priority, and mopeds, as was mentioned before. And NCI extension was submitted to the ISG recently. And the ODB, it's in still area directed evaluation. Ripple observation is work in progress, and this modification is standby. So related internet draft, for Storing Root Act, we have the call for adoption issued in January 26, but we have not got any feedback. So probably we will raise it again. And let's see if people want to work on that. And lighting diode information is going to be continued later. And the state of inactive internet draft, they are still to be continued later. So our milestones, these are done. Turn off and our leave. Okay, ODB repair was submitted, but there still is a correcting the feedback and use of Ripple info submitted. NPDAO as well. And then we have those milestones still active. Probably, yeah, we will have to update the dates here. And the tickets, we have mainly the tickets are in GitHub for Ripple observations, DAO projections, efficient routing validation, and capabilities. But as well, we keep some track in the old system for ODB Ripple, maybe mainly on the DAO projection. But the DAO projections are moved to the GitHub. Okay, Pascal, about the root initial state in Ripple, DAO projection. Are you online, Pascal? Okay, we cannot hear you.
Oh, is it better like this?
Okay, yes, now it's not now we can hear you. Thank you.
Oh, okay, I'm sorry, there was double mute on my PC. And maybe I can share the video. I don't know if people are constrained with video today. So do you want me to share my slides?
Oh, I have them here, but
okay, okay, please go ahead. I will ask you to yes. Switch slides. So yeah. So what can I say about this? There was 2 important and big changes, publication of the DAO projection draft 15 and 16, and the intent was to first do things that we said we would at the previous IETF, but also and mostly we wanted to simplify because it was getting complicated. I was getting feedback that it's complex, and we wanted to make it more streamlined, more everything is the same. And to do that, what we did is we realigned the operation of a track to the operation of the main DAG. Everything in a track smells, looks like the main DAG in non-storing mode, just that it's a local instance for a track and a global instance for the main DODAG. But otherwise, all the concepts and things that you know, and how in particular you use of REPL info to encapsulate, etc., all that you knew and understood with the main non-storing DODAG will apply to the track, which is a non-storing instance. So that's for that we had to do some changes, like we made the root of the track ingress. It used to be the egress for a number of reasons, but now so that you have a single destination. That was the main reason. Now we turned it into the root is the track ingress, meaning that the track can lead from one place to multiple places if you really like it to, just like the main DODAG. Or you can make it converging, like one ingress and one egress and multiple paths in between if you like as well. So we imposed that the main DODAG is non-storing, and the reason for that is that gives us an idea of the topology using the non-storing signaling. And we also imposed that the track itself is non-storing. So you know who's the root, you know all the steps, etc. In both cases, we can use storing mode to install segments so that the non-storing signaling now can be loose. So if you want to go from A, B, C, D, E, F, you can have non-storing which have a source routing header which says A, D, F, and have source routed segments which are B, C, D, and D, E, F, if you like it that way. So that makes it so that you have the best of both worlds, some state, but not too much, and the root can control how much state you get installed in the nodes, and then a loose routing header so that the size of the packet doesn't grow too big. Now you'll find there is an exception when it would be kind of silly to have a non-storing track with just one segment in it. Then the segment implicitly defines the track. But otherwise, we have a strict naming and convention that a track is a non-storing DODAG, and the segment is a strict sequence of nodes that you can have between loose hops in the track. And you can apply that to the main DODAG, and you can apply that notion of segment to a track as well. So everything has been simplified to a single model. You have basically a skeleton in non-storing mode that can be the main DODAG, that can be the track, and the skeleton can now be loose, meaning that you don't have to have the strict list of hops, because between two loose hops, you can have a storing mode segment. Now, you could, if you really wanted to, also have this loose hop signaled as another track, which means that when you are inside the loose hop, you encapsulate in another track. So you have source routing inside source routing. If you really wanted to, you could do that. But the more attractive model is when the skeleton, the loose structure, is non-storing, and just when you want to save, you have storing mode segments. And another thing that we did to simplify the draft is that and we'll see that later, but we split the possible things you can implement in six modes, basically. Just like in the main repo, we have storing mode, non-storing mode, etc. We actually split the DAO projection support in 6 profiles. You will see that they all inherit from this same overall design, that the track is a non-storing loose thing, and the segments join the loose hops of the track using storing mode. This is pervading, but you can actually build different things, as I said, and we made that different modes. So if you have for instance, an external standard body, like not Thread because I'm not using REPL, but maybe Wyson or whoever, who wants to use REPL in just a certain one specific of those modes, then they will have the clear explanation in the draft on how this mode works, how you do the encapsulation, etc. So we did a lot of big addition also, giving an example for each mode of how the packet gets encapsulated, how the track gets signaled, etc. So now you know exactly how you do things. Next slide, please. Okay, another thing that happened is we found that it was probably useful when you're forwarding a packet, and that's from an early implementation that a group at Cisco did. We found that it could be useful to signal in the packet that it's being forwarded along a peer route. It's already clear that it's being forwarded along a local REPL instance because the REPL instance ID has one bit which says it's a local instance. But they thought that, for their code path, it was more clear to signal as well that the packet is following a projected route. So we said, hey, there is a free bit in the hop-by-hop header in the non-compressed format. So let's use it to signal that we are following a peer route. That's something we discussed on the mailing list. But then that causes another problem, which is that 8138, the compression of REPL signaling for the data path, did not have room for this extra bit. And actually, it had room for things we don't need. Like the loop avoidance mechanism, which is not used here because you signal the path. So what we did in this draft is create a new 6-layer H, which when you forward along the track, the suggestion is do not use the normal RPI 6-layer H, but use the projected RPI 6-layer H. And for this projected RPI 6-layer H, we provided both an elective and a non-elective form. So if you have a source route, either where you can live without completely not knowing that it's a peer route, then you can still put the PRPI into the packet, and a node which doesn't understand it but doesn't need to know would know that it can skip it because it's an elective. But if your operation depends on the fact that every node understands the projected route, then you use the non-elective form. And then if a node on the way does not understand the peer route, then it will actually drop the packet. Next slide, please. Okay, so we kind of simplified as well the rules for the projected DAO construction, because you could have a lot of elasticity in whether you have one or more targets, one or more transit. And actually the transit in the PDAO is not the TIO as you knew it, it's the VIO. If you remember what a transit information is, it's basically how you signal your parent in non-storing mode with a little bit more information like lifetimes. But here you don't signal a parent, you signal a full path. But you still can think of a PDAO as a DAO, where instead of having a TIO for signaling just a parent, you have a VIO for signaling a full path. The target is still the same, that's where you go. So the VIO is the via how you get there, and the target option is where you're going as it was before. Like I said, we are trying to make it very, very homogeneous between what we're doing in PDAO and what you already knew in non-storing mode. A track is just one other non-storing mode, DODAG. Another simplification that we made is in the naming. Instead of having this route projection option, this RPO concept, which was yet another acronym to live with, we said, no, let's get rid of that. Let's just say we have the stateful VIO for storing mode, and we have the source routing VIO for non-storing mode. Like I said earlier, the non-storing mode signals the skeleton of the track, the structure of it, from where you go, where you're going. And if you have segments in between that are loose, then you use SF VIOs, stateful VIOs, to set a state in every node along that segment. And by the way, the track ID, etc., in the SF VIO for that segment of that track will have the same track ID into it as the main skeleton, so you can relate the segment with the main skeleton. That's pretty much it. Next slide. Oh, there is a typo here. It's not taken from the track egress. It's taken from the track ingress. Sorry for that. So like I said, to simplify implementation and documentation and also standards which would import just one profile, we described 6 profiles. We choose the same basic structures, but use them differently. So if you need to do this, then you will apply profile blah, and if you need to do that, then you will pick another profile. And also, like I said earlier, but I insist on it, everything you knew about use of REPL info applies. Meaning that if the packet is coming from the outside of the track and needs to be transported in the track, like think about it like if it was a tunnel. It's more than a tunnel, but you could think about it as a tunnel for a while. Then any packet which is coming from the outside has to be encapsulated. Same thing, any packet which is traversing the track may be injected by the root or coming from the outside. And that is to be delivered to a node which is outside the track. Like the target in the TIO is a neighbor of the egress, but it's not the egress itself, it's one of its neighbors. Then the egress has to decapsulate, exactly like the access router that serves an aware leaf would have to decapsulate. So you need to think, we are building a DODAG with the projected route inside the main DODAG, but it's still a DODAG. Everything that is in the main DODAG, but not inside this smaller DODAG, is external to this small DODAG. So it has to be processed like a REPL unaware leaf, if you like any external destination. It's not part of this track, it's an external destination. If it sends a packet into a track, we have to encapsulate it. Next slide, please. So yes, when we encapsulate, the source of the outer header is the track ingress. So think of it as a packet coming from the internet and being transported over a REPL domain. The root has to encapsulate it, same thing. But here it's going to be source, the DODAG root, so the ingress of the track, RPI, the local instance ID for this particular track, and it can be compressed with the PRPI 6LRH. And the destination, whatever, but the destination must be something which is a target for this track. So, and then again, as I said, we have the concept of source routing VIO, so it can be loose, it's source routed. We also made this change, and I also already introduced that at the interim, but it's good to say to the more global instance, global population. We encode the SRVIO in the DAO exactly like it will be in the packet if you are using 8138. That means that the node which will place that in the packet to do the encapsulation will do a strict copy from what it got from the root into the packet. And that's important because using the compressed form is easy. Computing the best way you do the compressed form is a bit more complex. It's something that the root already does. If you implement 8138, the root already does this compression. But now, since it knows how to do it, we decided to just let the root always do it and put the compressed form verbatim into the PDAO. So now the local root, the track ingress, will just pick from the DAO the source routing 6LRH and copy it verbatim. Also, an important thing which was there from the very beginning of this effort is when you use a stateful VIO, so the storing mode, I'm sorry, one intent is to use it in the main DODAG. So for specific path in the main DODAG, you can actually use storing mode just there to make the source routing header smaller, right? Because you don't have to have the strict list of hops, but now you can have a loose list of hops. Now, to be very clear on, this is a segment which applies to this track, or this is a segment which applies to the main DODAG, then the PDAO for the segment has the same track ID information, which could be the main DODAG actually, as the source routing thing. So you can really say, oh, I have this loose packet going down this either main geodag or going along a track. Let me find if I have a segment expressed in storing mode, which actually has the same track ID information, main geodag or this track. And if I have that, then I can forward to the next loose hop using this segment. So you have to do this matching of the loose source routing and the segment in storing mode that goes between the loose hops. Now, there was a question on the mailing list. Could we have a track in which we inject not all the packets for the target, but only a subset of the packet with some flow information? Like if, you know, it's this flow label or this 5 tuple or anything like this. So the question is still open. I mean, I've not seen much expression of the need for doing this. It seems to me somehow that it could be a different draft, because it's kind of saying, okay, here is a way to express a policy, and if you have this policy, you might use this track or that track. And we could link that kind of policy matching to either DetNet or segment routing or I don't know what. So right now, I'm not very clear if it has to be something which is specific to REPL and that we have to indicate in our own RFCs, or if it's just something that will, when you deploy a protocol, a global thing like YSON that incorporates REPL, 6LoWPAN, and many other things, maybe they could say, oh, basically you need to have a match, and you could use a segment routing policy or something like that. And then we don't need to define anything. It's just the complete bundle of RFCs that they use for the solution, which has this other component for doing the flow matching. Next slide, please. And if you have anything you want to say or any question, I'm more than willing to answer. Ines, how much time, because you extended my time, but now I'm lost. How much time do I have?
You may have another 10 minutes.
Oh, whoa, I'm rich.
I know I shouldn't tell you that. You'll use 20.
Okay, thank you, Dominique. So yeah, I already presented the slides at the interim, but it's worth, I guess it's worth showing them again to the wider audience. And even for those who already saw them, probably it's not fully obvious how things are done. So basically, you have to signal when you define a track or when you define a segment, you have to signal where you want to go. So that will be the targets. For instance, on the top left here, you see targets B and C. That's where you want to go. So that's going to be the destination address in your routing table. And you either have an SRVIO, one SRVIO only for the simplification, or one SFVIO only for giving you strict hops if it's an SFVIO, and strict or loose hops if it's an SR, source routing VIO. Okay, so based on those basic tools, you can do a number of things, which, as I said, we divided in profiles. And now we are going to go through the 6 profiles to see what they can do. So profile 1 is actually the one thing that I promised we would be doing when I suggested this work to the role working group. And the idea was not to build track at all. The idea was just in the main non-storing geodag to enable a hybrid storing, non-storing world where if the root knows how much state can be used for routing in the nodes, then it could actually go and program the nodes for just at the maximum that amount of state, but no more. And use that at the best possible place to save source routing headers, so to save bandwidth and frame size in the packets. So if, for instance, if you have a very long line to get somewhere, you want to express it as a loose hop in the source route header, but then along this long line, you have to install a storing mode route, which will enable to join the loose hops. In this example, I have two such loose hops. One is A to C. We want to save the signaling of B. And then we have C, D, E, F. We want to save the signaling of D. Okay, and we could also, well, you'll see there are little alternates whether you want the destination to be the track egress or the destination to be a neighbor just after the track egress. And actually I show in this diagram, I show both cases. I guess I do. Okay, so the first thing that we have to do is build this track. But in profile 1, the track is the main geodag. Profile 1, you don't have the concept of a shorter path inside the geodag using a track. It's just we have the main geodag. We have all these graphs that may have those long lines, and we basically want to do some compression here and there by hybriding and with some storing mode. And so to do this in this example, we need two PDAOs, PDAO1 and PDAO2. PDAO1 enables the compression of the CDE path. Okay, so it can be now just a loose hop CE. And we also want to compress ABC and just signal AC in the packet. So now the source route header from the root to F would be basically signaling A, C, E, and finally F, which could be in the inner packet, which could be anywhere, but it really depends on what you're sending. But basically, the important thing I want to say is the loose information now in the SRH is A, C, E. We have skipped B, we have skipped D. And there could be many more, right? You don't have to skip only one hop. You can skip 5 of them if you want to. We do that 2 times. We don't necessarily do that as a single line. You see, we skip B separately from skipping D, which means that if you have ABC, CDE, and CD prime, E prime, the compression of B doesn't have to be done twice. I mean, the hop ABC has been compressed with PDAO2. It works wherever you go from C, right? So that's one good reason for doing it in two shots. So PDAO1 is sent by the root to, remember, we send the PDAO in storing mode to the exit. So we send it to the egress, which is E. So PDAO1 flies to E, and it signals the target of E. Doesn't signal, in this example, it doesn't signal any other target. You could have signaled F if you wanted to, but in this example, we place F in the packet. It's a choice. So basically, the SFVIO says CDE. So E will pass it to D, D will pass it to C. All of them along the path will set up a route to the target. So C and D will have a route to E. Okay. And the only interesting thing that we've built here is really C having a route to E via D. You will find the draft. It's all explained with tables and all. You will see who installs what, because you have the neighbor entries and you have the routing entries. So the only routing entries that is really set by this PDAO1 is C now as a route to E via D. Okay. And so when the PDAO reaches C, it installs that route and it sends the PDAO ACK to the root. So now the root knows that C knows how to get to E without signaling the source routing header. Same thing for B, but you see that I could have sent the PDAO1 to C. C would have terminated the first sequence and started the second, but we can also, and this is what I do here, we could also consider that the segment ends at B because B knows about C being a neighbor. So you don't need really to do what I did on the right, which is send the PDAO to E. On the right, I send the PDAO to E, which sends it to D. And the only thing that D learns from this PDAO is that it can reach E via E. And it's something it really knew. So I just show that it's possible, but probably the best thing to do in this case is to send the PDAO, what I do to B directly. Like PDAO 1 could have been sent to E, PDAO 2 is effectively sent to B. So with this, B says, okay, the targets are myself, fine, and C, okay, do I have C as a neighbor? Yes. So this PDAO is valid. I can reach C, I can reach myself. I'm a valid egress for this segment. What is the SFVIO? AB, okay. So I need to pass it to the guy before me, which is A. So B passes the PDAO to A. A looks at the PDAO, says, okay, what do I see in there? First, the targets are B and C. Okay, let me look at my routing table. B, I knew already how to reach him, right? He's my neighbor, but I can reach C via B. Let me install C via B in my routing table. So at this point, C as E via D, and A as C via B. And A is actually the first in the SFVIO list, so it sends the ACK to the root. The root gets that, and now it knows that A can go to C, and C can go to E. So now in the source route header, instead of saying A, B, C, D, E, F, the root can do A, C, E, F. Okay? So in this case, the track, as I said, is the main DODAG. Just same thing. It's just that the main DODAG is a global instance, and another track that we'll see in the other profiles are local instances. But it's exactly the same game. A packet comes in the root has to encapsulate it for the track, which is the main DODAG. So it will put the RPI of the main DODAG. It will put a source routing header, but now it can be compressed, and the source routing header will say ACEF. Okay. Remember, the target is where you're going, it's what you install on the RIB as the destination, and the VIO is the path to get there. Okay, so that's profile 1, and that's what was originally promised for the work in PDAO. Next slide, please. So the first thing that I got as a request from the working group when we started this work is, hey, could you please do the same thing but expressing quote unquote the segments as non-storing mode as well? I said, well, okay. When you do non-storing mode for expressing quote unquote this segment, as it goes, you have to re-encapsulate to place the source route header, which will allow A to reach C, which I represent in orange in this slide. You see why it's written track 2 and track 1. It really means A. Okay, A has a loose source routing packet to get to C, but it needs to send it via B. And so it needs to encapsulate it with a routing header, which will express how to get to C, because now everything is a routing header. So you end up with a double encapsulation. The root takes the packet from the outside of the DODAG, encapsulates it with RPI 0, and now A has to encapsulate it to C via B. So the bottom line is, when we're using non-storing mode to signal intermediate hops between the loose thing, you're actually re-encapsulating the packet in another track. Whether it's the main DODAG or that was the outer thing, well, the first encapsulation. The second encapsulation is a new track. That's one of the realizations we ended up doing in the process of defining PDAO, is as soon as you use routing headers, you have to re-encapsulate, which means really another track. So to make this work in non-storing mode, same thing as before, we have to create 2 tracks, track 1 and track 2. So it's easier in terms of signaling because the PDAO in non-storing mode, so the SR PDAO VIO is really passed to only the ingress. The ingress gets it, gets the source routing header, just answers immediately. So you see PDAO1 being sent to C and C answering, and PDAO2 being sent to A and A answering. Okay, so it's easier for signaling. You don't have to forward it along the path as we did before. But the operation is less efficient and more complex because you have to re-encapsulate and decapsulate. A encapsulate, B decapsulates. C re-encapsulate, D forwards using the source route header, E decapsulates. Okay, and like before, you could end up in D just like we end up in B. That's why I say there are two ways of expressing roughly the same thing. It's just that in this case, it's more obvious that B will decapsulate and forward the packet, which is still forwarded along the main DODAG with RPI 0 in the outer header now. From B to C, that's the same packet that was from the root to A, because B has decapsulated. Reaches C, C needs to send it to E. Oh, guess what? To send it to E, I have this SRVIO, which says DE. Okay, I have to re-encapsulate. So for A to encapsulate and C to encapsulate, we have to define two tracks. Next slide, please. And how much time? I still have 5 minutes, right? Or am I wrong?
You already used up the 10 minutes by large. But
okay, so
I'm checking with the other presenters, so you can have another 5 minutes. So try to give the high level summary.
Sleeping, I don't need them. But
can you just summarize, the differences between the profiles so we get the high level view?
Okay,
and
so
we'll schedule an interim to dive into the details, which are absolutely exciting, but sorry.
Yes, I'm sure. Okay, so no worries. I mean, actually, everything is expressed in the draft anyway, with examples, etc. And you'll see that the profiles are mostly expressing the same thing, but instead of having the main DODAG, now you're trying to do a shortcut, because that's the second thing that the group asked me after doing the non-storing mode segments, which really are tracks, is how can we do shortcuts inside the DODAG? So not just along the main DODAG, but inside the DODAGs. So all profiles starting at 3, so 3, 4, 5, 6, will be doing those shortcuts, avoiding going all the way to the command parents and down, or in non-storing mode all the way to the root and down. Now we can do shortcuts, which means that we are building tracks, DODAGs, where the root is one node in the network on the left, and the egress is another node on the right. And like I said earlier, we made it so that the root is the ingress, meaning that now a track can have multiple egresses. Profile 3 is the case where the track, I mentioned that earlier, but the track is implicit. Because all you're doing is giving me a list of hops. So you're saying, oh, I want to get from a node which is next to A to a destination F. And to get to that destination F, which is a neighbor of E, all I want to do is go A, B, C, D, E. So you can express that as a storing mode path, which is just represented by this PDAO1. But you don't really need to do an encapsulation. Encapsulation. You do need to do an encapsulation, but to signal a track, which would have the exact same information and saying ingress A, egress E. I mean, that would be an additional PDAO for just nothing match. So when you signal PDAO1 as expressed here, you can think that implicitly comes with it a non-storing PDAO, an SR VIO, which says AE, right? Ingress, egress. It's implicit. You have signaled by this segment. I have also signaled implicitly a track. So that's profile 3. That's how you can do. Next slide, please. That's how we can do the simple segment, which is a track by itself. In this case, so 3, 4, 5, 6, I forgot to say, because you're doing left to right, you need sibling information option. For 1, 2, you don't need the new option that we have in the PDAO draft, but for 3, 4, 5, 6, we need the sibling information so the root can know actually what the neighbors are. In this case, we are using a storing mode track to signal the same path as before, but now we have a strict I don't say why I say loose hop 1, because it's really strict. I mean, it's so sorry for the typo. The hops are not loose anymore. In this case, the hops are strict, and it's basically you signal the exact same case as 3, but using a non-storing mode. Next slide, please. So here so every odd number is using storing mode. Every even number is using non-storing mode. So what we've done here is pretty much the same thing as we did in the first profile, in profile 1. But now you realize that the main DODAG is replaced by a track. And profile 6 is the same thing, but using track within track. And that's pretty much it. Okay. So there are some questions which were really already asked during the interim. I don't have much time, but I would like to...
Pascal, can you go to the conclusions, please?
Yes, I'm done. I mean, I'm saying I just want to address those questions on the mailing list. So do we need to do more on loop avoidance? That's the last slide that you have here. When we have the packet, the PDAO request, who sends it? So those questions that you can read, I would like them addressed on the mailing list to solve it. And pretty much we are done after that. That's my conclusion. Is once we resolve those issues, we're pretty much done, I guess.
So what are your next steps? Do you need feedback from the group? Do you need...
Yes, exactly. I need to discuss those items that you can see in front of you and get feedback from the group. There was the question of whether we do flow filtering, and then whether we want to do more on loop avoidance, whether we want to extend the capability to send a PDAO request. So that's a message which says, please build me this track. For now, only the track egress can do it. Do we want more? How do we maintain the neighbor state? You know, we now have the sibling information option. How do we maintain the state of the sibling? Do we say, oh, use ND or something? It's not really detailed. And the last one is already done. I mean, we already signal pretty clearly. You'll find the draft that depending if you're using SRVIO or SFVIO, basically implicitly the egress is a target when you're using non-storing mode, but it's not. You have to signal it in storing mode. Same thing for the ingress. It's signaled in storing mode. It's not signaled in non-storing mode.
So can you please write up those questions on the mailing list?
Yep.
So you...
Ilya Babet have a question?
Sure. Yes, Ilya, go ahead.
Yes, thank you. Hi all, thanks for the great presentation. I'd like to ask if there is any profile that I was looking at, searching for a profile that we send the PDAO to all of the intermediate hops, not only the ingress or egress. That would have some benefits. Obviously, it would also have some disadvantages like scalability, but how do you analyze that?
So though we have not designed for it, I mean, you're the first one asking for this. In 6-ish, when we looked at how we could establish a path, we considered it. We called it the shower model compared to the basically usual voice call model that we used for RSVP, for instance. But we found that it was consuming, if you have a big DODAG and the nodes are deep into, doing what you're asking could be very costly. And then if any of those doesn't work, then you have to undo everything. So we thought it's a bit harder from the root to control everything. When things work, it's much easier to just send to the egress and let it forward to the ingress. We did that for economy. Now, if we can do this on the mailing list if you want to justify why, in which cases it could be useful to also define what you said. I'm not against it. It's just that we have been doing a lot of effort to simplify the draft, and now you're asking more complexity again. So.
Okay, so we'll carry this on the mailing list.
Yep.
Okay, thank you very much, Pascal and Ilya. Michael, are you there?
You have slides. I don't need to project.
Yes, I have the slide here that you sent me.
Okay. So yeah, so status of this document. So we adopted it after sitting around for a while in March of 2020. There was some revisions to it last year. And then we had this document from Human. Do I say his name right? I hope so. On the this DODAG metric for joining based upon the size of the DODAG. And so the suggestion in the January virtual interim was that we merge this into this document. And so next slide, please. So this is it merged. Those are a couple sample of some of the diffs. Of course, you can go read them all in greater detail. Next slide, please. This is essentially the core of the thing. You'll see that there is a new DODAG size, a 16-bit. Sorry, it's a 16-bit number. No, it's not 16-bit. It's a 16 bits with an exponent and a mantissa there, and that essentially that gives us the size value. And then there has been some discussion, I'm sorry I didn't write a point about this, between Pascal and Newman and some others about exactly what are we measuring, and with Pascal suggesting that the thing that we actually can know about in the case of particularly non-storing mode, the root knows the number of roots that he has, not necessarily the number of nodes that there are. I'm found it difficulty to figure out, are there situations where we have more nodes than we have roots for them, or if we have fewer roots than we have, sorry, if we have more roots than we have nodes. So when would those numbers not be the same? And I don't have an answer to that question, and Pascal will probably answer it in the queue. Just give me a moment, Pascal. And the other side of the discussion is, I think, do we have any concept of what we would do in storing mode? And the answer may be that we don't have any idea to how to measure that unless we have some other telemetry. Go ahead, Pascal. Go ahead, Pascal. Okay. You wanted to say something, but your hand's still up. Next slide. Maybe we lost him.
I'm sorry, I was muted when I thought I was not.
Yeah.
Is it okay now?
Yeah, go ahead.
Okay, so I was saying, hey, first thing is storing mode. Storing mode, the only thing you know is the number of final destinations and the number of children that you have. So the root will only knows number of final destinations. Now,
what do you mean
it might be
final
that
destinations? You mean
the addresses that are being injected in DAOs at this moment of time. So
right, but
how many routes? Talking storing mode.
Oh, I see. Yes, of course, because we get all of them summary as a summary up to the list.
Exactly.
Yes, that's right.
So,
okay.
so the only thing you see is number of addresses. So it might be that this node is sleeping, doesn't need to contact the network for 2 hours, and decided not to send a DAO. He will send a DAO in 2 hours when he wants to be reachable. In this case, you don't have an entry for him, but he's there.
Yeah.
And the opposite case is this node which wants to have 2 addresses for its own needs. I don't know why, maybe one for management, one for other purposes. And having 2 addresses with 2 entries in the routing table, but a single node. So it's just 2 examples where the number of routes doesn't match the number of nodes. Now, in non-storing mode, you have a little bit more information. At least you know the number of parents. But at the last hop, you still don't know what's going on.
Yeah. So it seems reasonable that, this is an estimate, and I have a feeling based upon the discussion that we had around the 6TISH draft that is related to this, that there may be some desire to explain what it is we're going to do with these numbers down the tree, and some of this is a little bit of we want the standardized containers with the standardized meanings, but we don't actually know necessarily what we're going to do with them precisely until people do some experimenting. And I don't know how to capture that intelligently into the draft. Maybe the whole thing should be marked experimental. Maybe that's the right answer. But anyway, at this point, I think this is a welcome and simple change, and we should just proceed with it. And that's about it. I think that's the last slide, Inez, is it?
Okay, yeah. You have 2 minutes more, Michael.
Is there another slide? There's no new slide. Yeah,
Oh.
questions. That was the only question. Yeah, at this point, I think we should just proceed to reviews and publications, and I would love to have and figure out the question of, do we have to specify the semantics of what you do with all of this, or not? If we do, then we're going to have a longer conversation, and I think that we need to have some implementation experience with this first.
Okay, great. We can take that to the mailing list. Thank you very much. Okay, Pascal, you have 1 minute for questions.
Yeah, the question, it's not really a question, it's just basically there is the YSUN. YSUN is kind of important for Ripple. They have deployed millions of Ripple nodes, and they needed this information of having a rough idea of the size of the DODAG. In their case, it's one address per node, blah, blah, blah. So then they actually match us intuitively, Michael does as well, the number of routes with the number of nodes. And they needed this to balance DODAGs. So they already are using this information to, if you have 5 DODAGs, you want them to have roughly the same size. And so that's an important thing that they wanted to have. So it's very cool that we are actually giving that to them.
Okay. So that would be great to hear, I guess, directly from YSUN about that. I know that's Cisco has a lot of connection, but it'd be great to hear from some other people on that.
Okay, great. Thank you very much, Michael. Raul, please go ahead.
I hope everyone can hear me okay.
Yeah.
I'm going to present status for 2 drafts. One is the capabilities draft and the other is the MOPEX draft. For the capabilities, there had been an update before the last interim, primarily based on Dominic's feedback, extensive review done by Dominic. Thank you, Dominic. But after that, there has been no changes. I would like to summarize what the document does here. Can you go to the previous slide, please? Yeah. So it basically talks about the capability options format. So capabilities is something that a node might possess and might want to handshake with other nodes. A node might want to know some of the capabilities for the other nodes, adjoining nodes, or nodes, not necessarily adjoining nodes, but any other node. A root might want to know specific capabilities of a newly joined node. So all these use cases are covered by this document. There are 2 specific capabilities which are instantiated as part of the document. One is the capability indicators flags. These are single bit capabilities. One of the capabilities which is already defined is about 6-law RH, whether the node supports 6-law RH compression or not. The second capability is a routing resource capability, which basically tells you how much of the routing table size you have and how much of it is already used. And then we have query and response signaling, which came up later in the document post the working group feedback. And there are guidelines for defining new capabilities. So there are certain flags in the capabilities options, and how one should be defining those flags or using those flags has been defined in the document. There's only one important must that I need to bring to the notice of this working group. It's that the capabilities will be mandatorily enabled if the network uses MOPAX, essentially MOP greater than or equal to 7. Next slide, please. And this gives you a very high-level view of the messaging format. If we have a new capabilities options, and then there are TLVs, nested TLVs. The JIC flags those are the flags which are actually defined by the MOPX draft. And as I had mentioned before, there is capability indicators. There are two capabilities which are already defined. One is the capability indicators, and the other is the routing resource. And then there is a way for the capability query and response model. There is a way to request a capability set, or send the response for that particular capability set. And there are several scenarios. So that's the only complicated piece, I would say, in the whole draft. But otherwise, it's a pretty straightforward read, it, I should say. Next slide, please. And here, I'm giving some details about how the query and response model works. Basically, the primary challenge is, you might have capabilities sent across, multiple messages. Is it possible? So if you're sending back a response saying, I have all these capabilities, it might so happen over a period of time that this capability message might exceed the MTU size, and how to handle that. So that is one of the primary challenges that has been handled in the draft. I would really like to see some feedback from the working group on how the handling, will that handling be enough. Next slide, please. And that's pretty much about the capability status. Now I'm going to talk about MOPX status. Well, the document, what it does is, this is a very straightforward document in the sense that it doesn't have any new messaging involved. It defines the MOPX. If the base MOP is equal to 7, then you basically use the MOP from the extended MOPX option, control option. That's the core of the document. It explains various conditions, and it basically tells what happens if base MOP is so, and if the extended MOP is present, or if the base MOP is 7, and what happens if the MOPX is not present, how to handle all these scenarios. In the past IETF session, one of the points that was discussed was, there are new control options being added by a lot of new drafts out there. And is it possible for us to make sure that any new control options that are getting added in the future could be backward compatible? Can we handle the backward compatibility issues in a graceful manner? And that's where the third point comes into picture, which is extending the RPL control options, which we decided to merge in this particular document. And I'll talk about that particular point in detail in the next slide. Next slide, please. So, extending the RPL control options, we needed few bits. Currently, we have an option type. If the first bit of that option type is set, which means essentially it's an extended control option. If it's an extended control options, there are additionally optional flags which could be set. And in the optional flags, you could see that 3 flags are already defined: J, I, C. So basically, the problem is, if you get an unknown RPL control option, how would you handle that? How should a node handle it? Currently, there is no, there are 3 possibilities on how to handle it, and basically the 3 bits take into consideration that. The first J bit is, if the J bit is set, it means that if you don't understand the option, join only as a 6LN. If the second bit is ignore bit, which means that if you don't understand this control option, drop the whole message, ignore the whole message. The C bit is a copy bit, which is you copy the control options as it is in the message, and let the upstream or downstream node decide. You just act as a relay. So this is very much similar to Carsten gave a feedback, and I had a look at COPE has similar, COAP has similar bits, and I had a look, and I tried to take some inspiration from those bits as well. Oh, I think Pascal has a question. Is the hand raised? I can take it.
It's a very quick one, Rahul. Thank you for the presentation. And hope everything is good with you. I'm just thinking, I already had the problem of thinking about it, but there could be cases where if this guy does not support the option, it should not join at all. And since you have 4 possibilities and you're only using 3, I was wondering if you could play with the G and C bit when J is 1. Based on the C bit, you could say, or you join as a leaf, or you don't join at all. Because could it be that, for instance, the bit says you must compress. Just an example. You must compress. And if the node doesn't know to compress, there should be a way to say you don't join at all. So here it's not that, it's understanding an option, but if the option could be to say to compress, actually, I don't know. It's not the right example, but you see the point. Maybe there's a case where you don't want to join. And since your C is not reused, why don't we say, hey, J1, C0, you can join as a leaf. J1, C1, you don't join at all. Sorry, but you don't speak the right language.
Okay, that makes sense. I think we should let me think more about this. Pascal, point noted. Thank you very much for the feedback. I have lost the slides. Can you hear me still? Okay, I'm done with my presentation. Just the next slide, please. Ines. Okay, so there are no tickets open, by the way, for any capabilities or the MOPEX draft. All the tickets have been taken care of, before the last interim itself. I saw that, Ines, you mentioned in this summary status before that there are 6 capability issues open. I just verified there are no issues open in the context of capabilities or MOPEX.
Okay.
I mean, especially for MOPEX, there is no complex handling involved. For capabilities, there is a complex handling involved because, some sort of complex handling, I would say, just because of the addition of new messaging. MOPEX is basically a precursor for capabilities because capabilities would be enabled only if MOPEX is supported. Basically what I'm trying to say is, let's prioritize MOPEX over capabilities, and if we can get more reviews for MOPEX, that would be great.
Yeah, that would be great. Please review this last version of MOPEX so we can go proceed with the last call. Okay.
Thank you. Yes, thank you.
So, thank you very much. We have 1 minute over time, but I think we have action points that we are going to send to the mailing list. So thank you very much to everyone. Dominic, you want to add something?
Well, congratulations for achieving, unlocking these 4 drafts that were sitting, and
Yes.
I know that many people are going to be happy that when C318 is out, and so that's a great achievement. Congratulations to all. And then we can focus on the next drafts, and we have a lot of work ahead of us that can now proceed. So that's good news. Yes,
and as well, we mentioned briefly that we have in GitHub this RFC 5550Bs. So take a look and comment. So we are going to start working on that. Okay. Thank you very much all, and have a nice day.
Thank you. Have a nice afternoon, morning, wherever you are.
Yeah.
Thank you, Charles.
Thank you.
Thank you.
Bye-bye.